with the introduction of Python, but before that, I always go over the few things. So again, you want to check the sign-in link. You see, find that in the chat room, or I believe you also find that in Slack, and then sign in for attendance for today. Again, especially if you intend to get a certificate of completion of this training. Later, there will be a link for evaluation. So again, check that link in the chat area, and I believe also in Slack for that link, and then do the evaluation. Other things, next week, which is March the 30th, March the 10th and the 11th, the host institution, that is the institution, Howard, that is hosting this program here, is on spring break. So there will not be any instruction or lectures next week, Thursday, and then Friday, but we'll continue the week after that. That will be March the 17th and March the 18th. Again, check the chat area, check Slack. There will be announcement and updates so that you don't miss anything. And then also, I believe, William, there will be TA sessions tomorrow.
Yes, from 6 to 7. 6
to 7 p.m. Eastern Standard Time. So again, welcome to day 2 of module 2, Introduction to Python. And let's all welcome Dr. Musa Doumbia for this presentation. So Musa, it's all yours now.
Thank you. So I'm a little bit behind the schedule, so maybe I can share my experience with you guys. My background is math. When I was learning programming, I found it difficult to follow the instructor and then live coding at the same time. So maybe if you guys just follow me, and then later on you will write the code. If you have problem, then you go to TA session, right? In that way, we can cover more, right? If right, you may, right? Because I'm a little bit behind the schedule. Okay, so the first thing that I want to mention today is set, right? So like dictionary set will be within the curly brackets, but it doesn't take a repetition, right? For example, let me define a list that have a repeating numbers in there, and I'll apply set to it. The set method, it will say that it will take care of, it will remove the repetition, right? So they have to be between curly brackets. So let me say, new list equal, for example, 1 1 2 2 2 3 3 4 4 4, for example. Right. So I have this. Good morning. So I have this list. One comma is missing. Yeah, double extra comma. So now, if I use the set to this, so SAT new list, right? New list. It just give me 1 2 3 4. So it doesn't, accept the repetition, right? So you can also build a set of tuple. You have a tuple, then you can set of that. Then you have it. You can also manually build it directly. Your a set equal these, right? 1 2 3 4, right? So people use set method if they want to remove a repetition, right? And then if you run it's a set, right? So you can build it of tuples, right? Like I said, you can set, let me say tuple set equal, I would say SAT, and then here I will have a tuple is inside her, right? So tuple should be between parentheses, then 1, 3, 5, for example, right? And then let me see what the tuple set look like. Right, so give me a set. Right. So in addition to sets, we also have something called, since I just mentioned, let's go to tuple. So tuple are unmutable. These are unmutable. Right, you cannot unmutable. So you cannot update the value. For example, if I have my tuple equal, for example, 1, 2, 3, 4, 5, right? I can unpack this tuple or my tuple, for example. Right. I can unpack it. I can access the element in this thing, but I cannot update an element in this tuple, right? For example, I can unpack it with how many number I have 5 elements. So I can say A, B, C, actually A, B, C, D, E. I can say that this is equal to my tuple here. So this means A will be as 1 will be assigned to A. So this number must match. I have 5 here and I have 5 here, right? My tuple Y is missing, right? So if you run A, for example, A would be, oh, I got A twice. So A, B, C, D, E, right? So, right, A equal 1, if you say D, for example, D would be 4, right? But if I'm trying to adjust one of these, to update one of these value here, then I will get error message, right? For example, if I set my tuple, the first value, if I set my tuple, let's say I will assign the first value to, instead of 1, I want to say that is equal to 7, for example, right? Tuple, doesn't support item assignment, right? Okay, any questions so far? Let me look at the chat. I'm also here. Okay, cool. Right, so tuple set, now we can talk about some basic operations. Right, yesterday we were dealing with Boolean. So Boolean will require some logical operations. You're comparing different statements, so basic operation. So for example, in the Boolean, yesterday we were comparing 2 numbers, right? So for example, if I have a 1 less than 0, right? So this is it will return true if it is, right? This is a Boolean operation here. If 1 is less than 0, it will return false if it is not, right? So 1 is not less than 0. But if you combine this, right? Usually if you want to combine more than one operation, use parentheses. So if I say 1 is less than 0, or here I will use parentheses again, or let's say 12 is bigger than 5, right? So it will go through this. This is false. I only need one of them to be true. So because 12 is bigger than 5, then this will return true, right? And then this operation also, let's say C here, capital C equal C lowercase c. Python will return false for this because it's a case sensitive, right? But if combined is n to another logical operation, so for example, I have 20 is bigger or equal to 5, for example, right? Right, or let's say 20, for example, right? So because of n, both of them need to be true, right? Even if this is true, but this is false, this will return false, right? So the next thing that I want to talk about, since you will have a lot of opportunity to go through these type of problem during the lab. So I want to start there and go to if-else statement. So if else, elif, right? Elif statement. Okay, so I want this to be a markdown cell, right? So, for example, I will say if statement, so if some condition is true, do this, right? I don't have to return. So for example, I can say if hungry, feed me, or if, let me start with if true equal false, for example, right? Then I want to print, if that is true, if this condition is satisfied, I want to say, yep, that is. So that's if statement. So if it is false, then nothing will print. If it's true, we'll print something here, right? So instead of that, you can have, this is the case when this never print. Let me look at this message, okay. So I can change the condition, right? If 2 is less than 2 less or equal to 5, print, yep, right, and that's it. So we check a condition. If that condition is satisfied, do something, right? So it becomes interesting when you add else, right? And then elif, it becomes, because you will be adding more conditions. So if this condition is not satisfied, then else, what about this? If this is satisfied, do this. If this is not satisfied, do this. You can have as many elif as you want. And then if none of them are satisfied, then you come to else, then do this, right? So because I'm gonna be asking user to enter something, so let's say import the input. So input will allow a user, right, to enter a specific value. So usually the value that you enter at the int will be treated as a string. So if you want to convert them to number, then you have to specify that, right? So if you want user, a prompt to ask user to enter something, you will use this function called int, right? int, right? So let me here input, then so an example is int what is your name, right? Then, right, what is your name? Then what is that? As an input, right? As is not integers, but input, input, right? So what is your name? Then it will ask user. So if you look at this, it becomes as a string, right? Even if you say input, please enter a number, please enter a number, right? Then even if the user enter a number, let me leave some space here. So let's say 12, see is a string, right? If you look at, let me assign a variable to it. Let's say num equal this. And then I want to try the type of number. So if I say type of this number, you will see that it is a string, right? So if you want to have as a number, as an integer, then you can specify here int. Then if I enter 12, then now it's an integer. Okay, let me see if somebody got a chat. Is there a different initialize? Is there a way to initialize? Yeah, right. So you can, yes, there is, right? You can also, if you want it as a float, right? So what is your salary, right? What is your income? Then you want this to be a float, for example, right? So let's say 20,000. Oh, what did I do? Oh, that. Right. So if I look at that, it is a float. Another questions? Oh, yeah, you can do that.
So I think the user is coming from a programming background where he's saying if I initialize a variable to a type, then when I ask for the input, the variable is going to be of the type. Yeah, which I don't think is true, but
let's see.
To try it out.
Yeah, I don't think so. Let's say here num equal integers here 0, and then I will ask user, right, enter a number. So now let's say 4. Okay, let's look at the type. I look like integers. Oh, because of this, let me remove this. Because I convert it to a float. So let's say 4. Yeah, it doesn't. It doesn't do that, even if you initialize it. Okay, so let's talk about if-else, right? If-else, so let's say, I want to have a list. Let's say I want to find the maximum of 2 numbers. So I'm going to ask the user to enter 2 numbers, right? Then I will compare the 2 of them, and then I will be printing the maximum, right? So I can do that, or I can also go through a list. Let's say here EMP name equal this, for example. Let's say Josh. See. So we got this name, this list of employee name, for example. Right. Then I have a name. Let me make that. So I have this name here. Let's say I have a new name equal this. Let me see, something close to just so John, for example. And I want to check whether or not it is in this list, is in the employee list, for example. So the hard way to do this is to compare this name to each one of them in the list. Not, assume that you have a You can go through all of them. It's not an infinity of a name. So you can say, this is the hard way. If name equal this, first I'll go Josh, right? Or, right, name equal that. I want to go through all of them. If that is true, then I would say yes, it's an employee. If that's not true, then I would say not an employee. So name equal Alan. So name equal Sarah. Right. So this is now advice. Name equal Sam. Name equal Adam. So if that is true, if it is equal to any one of these, then I want to print employee. Yes, it is an employee, or he, or let's just put employee. Right, so else, right, else is not an employee. Print not an employee. It's not an employee, right? So this is false, so it will print not an employee. No comma here, right? You can put parentheses, Alan, or that, or this, right? So either this, right? You are comparing to all of them, right? So it's not an employee, but a quick way to do this, because we learned this last time. You can just say if name is in, so if name is in this employee name, right? If name is in that, if name is here, print employee. Else, right? Notice the if and the else, are aligned. So the indentation is very important with Python. So now here, not an employee, not an employee. So if I change name to Josh, for example, then they both will say it is an employee. Right. So if else, so you check in condition, if that is not satisfied, then else do this. If this is true, do this, else do this. Right. Any question? Questions? Okay, so we can compare numbers, right? So we can compare two numbers to find the maximum. Let's say I want to say N1 equal input. I can say int if I want it to be in an integers. So int input. If I want it to be just a real number, I will put float here. So input. Please enter the first number. Please enter your first number. All right, so that, and then N2, I'll say second number, and then I'm going to compare these two. And click on that. So this is what I will do. I will say if N1 is bigger than N2, then I gotta set my max, right? Right. Then let's say M is a maximum here, right? Then if N1 is, if N1 is bigger than N2, right? Then I would say the max M equal me call N1. So else. So this else is N2 is bigger than N1. So M equal N2. And then you want to print. Now, once you're done with that, you want to print the maximum. Right, of the two number is. So if I want, I can use the format method, right? Right, so I will do this. And then that format, usually use format when you have more than one parameter to fill in. So I will say here M. Right. So this will return the maximum of the two numbers. Okay, if indentation M equals 0. Oh, that. So let's say 12, and then let's say 13. So the maximum of these two is 13. So let's say we want to find the factorial of a number, right? You remember a factorial of any number content itself. Let me see if I can get my pen. Actually, this is N if. So maybe we should go to this is else if. So elif, we can go to elif first before we do that. This is if else. So let's do elif. So elif. So if elif, right, and else. So for example, let's say I'm printing student grades, right? So I can start with if grade is bigger than is greater or equal to 90, return, right, or print A. If grade is less or equal to 90, that would be B, right? Or if grade is greater or equal to 80, that would be a C. I mean, less or equal to 80, that would be a C, and then go on and so on. Or I can use the if condition on that. I can also, yeah, let's do that. Right, elif. So if let me get a basic one. Let me if grade. We didn't define function yet. Let me see. Boolean. Yeah, we didn't define function yet. So let me look at the list. We're gonna go to a list. Leave for loop. Okay. Look at it here. Okay, a leave statement else, and then for loop. Okay, so a leave for loop. All right. Okay, so Now let's go to for loop. Right, so we got the, because of the time, elif. Okay, so let's say the list. Let me go to our list of employee. Okay, so I want to go elif, going through this list. So I want to check if the first name, if the first character of the name start with A, for example, right? Then I will do something. If it start with J, I will do something else. I will do something else. And that I have to for loop through it. Okay. Or let me just modify this. So if name equal, if name is in this employee name, then I will do this print yes. So I will say elif. So elif, if the first name, if you start with the first character is equal, let's say you start with J, for example, I will say not quite. Right, not quite. But not sure. And then else. So else, I will say, well, so to say an example where you can use elif, because I don't want to for loop through it. We didn't talk about for loop yet. So I would say here, not employed, not unemployed. So we got our name here. Name is Josh. Right, so what am I? Elif? No, not this one. Yeah, right here. Right. So it is yes, because the name was equal to Josh. And then Josh was among the employees. So if I change this to John, right, for example, then if I want this, right, not sure, right, if I change it to this, then it will be not an employee. So that's elif, an example of elif. Now, after elif, for loop, let me look at the chart. Yeah. Short code, yeah. So let's talk about for loop now. For loop. I think that's the next thing. Yeah, for loop. Okay, I think that's the next thing we need to do. So if you want to loop through, let's say a list of items, and then if some condition is satisfied, then you do this, right? So for example, I have my employee list. I can do this for name. So I would say for name in employee name, EMP name, I believe. Let me have, right? Then for name, I can just say print name. So this will print all the name that is in there. So let's just say print name, right? So you print everybody's, right? Then you can add some condition here. So you can say instead of name, you can put X. It doesn't have to be name. Let's say for X in employee name, right? Print name, print X in this case, right? So in fact, you don't even have to have alphabetical. You can have this, except for this in EMP. That prints that underscore, right? Then we'll get it, right? So you can add some condition, right? Let's say for name, right? In this employee name, right? So if the first character of the name is right, the first character, so that's 0, index 0. If that is equal to, let's say A, right, then you want to do something, right? Print print name, for example, you print the employee whose name has, start with A, right? So you can do that. Else, then nothing will show up. Let me bring this up. So if the first character start with A, you want to print that A. And then what happens sometime you might have, let me get the employee name. Let me see somebody name here is Abel. That's a lowercase, right? Then you don't want to miss that. If you want to get everybody whose name start with A, then you can make this one lowercase, right? Because if I do like this, I will not get Abel. I won't get Abel, right? Abel is not here. But if I take this to be lower or upper, right, then it will give me that. So let me put this A. I'll put here first character that lower, right? Yeah, question here. Yeah, you can do that. You can absolutely do that. Yeah, I can do that, right? So now he got Abel, right? He got Abel. So somebody asked in the chat that, can you start with an empty list and then go through everybody's name and then put those names in the list. You can append it, right? So for example, so I would say empty list. So empty list equal this. Then you wanna, for name in employee name, right? So if name sub 0, right, that's lower equal A, right? Then you want to append that. So you will say empty list that append, right? So we talk about append. So you want to add that name there, append name, right? And then after you do that, you want to print your you want to print the empty list, right? So print empty list or employee list. Let's call it that because it's no longer empty. Yeah, colon here, and then there should be indent here, right? Then it will come as a list, right? Good point. Yeah. So you can also go through the range of the length of your thing. So you see, we didn't need to specify else here, right? Else it doesn't care, it doesn't just do that. Unless if it does not, then you want to do something else, right? Then you can add it, right? So let's say for name in employee list, employee name. So you want to check the length of everybody's name, right? So if that name, the length of that name, let's say you have 4 characters, you know that that's divisible by 2. So if the length is divisible by 2, then you will return even, for example. So if len, this is a function, len of name, we will return the length. So len of name, if you divide that by 2, that is equal 0, then you can say print even length, for example. So if you want else, you would say add, right? So else print add. Right. So, right. So if you can also print the name along with this length, if you want. Right, you can print the name and then say, let's say Alan, right, is even length. No, what is that? Adams will be even length. So you have here Adam, you know, even length. You can do that, right? Okay, so that's for loop. You can now I can use for loop. I can use for loop to find the maximum of the number of factors of the factorials of some numbers, right? So if I pick 12, I know that the number of factors of the factors, let me write it here, the factors of 12, right, are, for example, you got 1, you got 2, you got 3, you got 4, and you got 6, and you got 12 itself. So regardless which number I pick, I will have the number itself and 1 in there. If I take 15, then I have 1 is there, 3 is there, 5 is there, 15 will be there. Right, so I have to notice that if I'm looking for all the factor of the numbers, so 1 should be one of the factors, and 1 should be one of the factor, and also the number itself should be the factor, right? So let's keep that in mind. I want to make that as a comment, so that Control Z. So I want to comment it out. Okay, so now let me try to find the factors of any numbers, right? So I want to ask the user to enter. So I will say n equal, so let's put integers for simplicity. So integers input, and then we'll say, please enter a number, right? So then here, I can print first, right? I can print first, like the numbers, the factors of the numbers are here. I can print before I even I go checking the number, because 1 should be one of the factors, and then n is also another factor. Let me see. Please enter in integers. Right. So yeah, so then n, the number itself will be a factors, and then 1 will be also a factors, right? The number and 1 will be part of its own factor. Now I'm gonna go inside and then check. You see here, I say I equal 2. So I equal 2 mean I got 2 factors already, right? And then the number of accounts, this is when I want to count the number of factors. How many are there, right? How many factors are there? So you start at 2 because you know 1 and n already, right? So now you want to see for I less than 1, n over 2. Why I do that, right? Why I do this, because if you look at, let me see, if you look at any number, so if you pick any numbers, right, you take half of it, right? Half of that number, let's say 12, right? Then if you take half of that number, then half of that number, let's say 6, 12 here, 6, then you don't have any other factor after half of the 6 except the number itself, right? Because 15 is a bad choice, let's say 12 here, and then I come here 4, and I got 2 also, and then 4 here, and then 6 here, and then 12 itself. So behind 6 is a half of 12. Behind 6, there is no other factor except 12 itself. So that's why I want I to be less or equal to n divided by 2, right? Because outside that, the only factor will be n itself, right? So that's what this means. So I want this I to be less or equal to half of it, because after n over 2, the only factor will be that, right? So let me just copy this here. I don't want to run. Okay, so let's come here. So I want to print this because n and 1 will be part of the factor already. Now I pick I equal to, right? So that's for now, I'm not gonna count the number of factors, right? Let me forget about that. So I will say while I, oh, we didn't talk about while. We did, okay, maybe this is an example where we're gonna talk about while. Look, so why I is less or equal to, so if this condition is true, n over 2, you remember n divided by 2 is an integer division, right? So if the division, the remainder, right, of I, the remainder of your n by I, if that is equal to 0, right, that means I is a factor of n, right? Because, for example, 12 divided by 3 is, the remainder is 0. So 3 is a factor of 12. Then I'm gonna print that. I'm gonna print that factors, right? And then I will increment it because I wanna go to the next number and then print I. So let's forget about counting the number of factors for now. So we'll say if n, the remainder of a division of n by I, if that is equal 0, right? Then I will say print I. Okay, so you see here, I'm saying the n equal here this, n equal this. So I want the factor to be separated by comma, or if I want them to be separated by space only, I will do this, right? Only by space, right? Then I will come here, print I. I need to increment. So I, right, equal I plus. So I mean, if that is true, I'll go to the next value of I. I'm adding 1 to it, right? So you will see this I equal I plus, but some programmer will write, instead of doing that, they will say I plus equal 1. It's the same thing. I equal I plus 1. You are updating, right? So this should be together. I plus equal 1. Now let me put in the usual way since we're learning. So I equal I plus 1. So the new value of I is the current value of I plus 1. Then we're going to print n. Right, so print, and the indentation is very important. Right, so print n. Right, the indentation f is this and this I are indented, and then my print, if I stay inside here, let me come. If I stay in here, oh, how can I move this? Right, if I stay inside here, look what is happening. And it's 12. So let's say 12. You see the difference? So I only want the factors of 12. So that's it. Right. So if you want to count it, then we start with 2 because we know 2 of them already. And then as long as this happens, then we'll increase the count also. Right. I think somebody is not muted. Right. So you start with count equal 2 because we know 2 already. And then we're going to say count plus equal 1. Right. So if you want sum, you do the same thing, and then we can print all of them. Right. So you start here, count equal 2. We got 2 of them. Right. Then we will say here count plus, right? Count plus, or count equal count plus 1. Count plus equal 1. Right. And then if you want to print, you can say print the number of factor right. So the number of factor is right. So count. So if you want, you can do comma, or you can use a string formatted if you want. So here, and then say count. Right. So if this is when you want to count the number of factors. Right. So the number of factors, 1, is that right? The number of factors. Why we got, oh, okay, 1, 2, 3, 4, 5. So the number of factors of, we start with 2. For each one of them, we are increasing it. Count equal counter plus 1. Let's say 15. Okay. So let me run this and see what's up. Okay, so what am I missing here? Oh, I started at 0, sorry. We got 2, we know 2 already, right? Because n and 1, that's the reason. Let me see here. Yeah, now it's working, right? Because we know this and we know this, right? Then that's how you do it. So in addition to for loop, any question about these? Questions? Let me go through the list. What's the next one we need to do? Yeah, for loop. Oh, and list comprehension, and then Lambda expression. We need to cover that, right? So list comprehension. List comprehension. So let's say we have this function, this for loop as a let's say here num list. I got a list here equal this, and I want to go through it. 1, 2, 3, 4, 5, 6. Then I want to square all of them. So this is what I will do. So for number, or I can say for I in this, in num list, then I want to, let's say, new list or square list equal to, I want to square everybody and then put in that list. Square list equal this, for example, empty. So for num in this list, then I want to append square list. I want to add so square list that append I square. So I square is 2 star, right? Then I want to print the square list, right? Square, oh, I said square. Okay, so square list. I want to print it. So this is the hard way. What are square list? One of them are not defined. Square. Name square list is not defined. I said square list. Oh, this one. That square list. Right. So this will return this. So instead of doing that, you could have used a list comprehension. So I would say list. So you start with. Let me start with this. In fact, let me copy this. Right. I want to copy this and then transform it. Oh, Control Z. So I want to take this. In fact, I don't even need the sequence because we already did it. I'll place it here. So with list comprehension, we start with what you want. So let me delete this. This one, I square will come here. Right. I don't need a kind anymore. So this go away. If I want to make a list comprehension, so you start with what you want. So take this, put it here. So because we're using list comprehension, so square bracket here, and then at the end you have square bracket also. So I'll say I square for I in num list, and that's it. Right, I square for I in num list. So if I want to see, I will say list, so that I will see it. So let me do that. See, it will give you the same thing. So you don't need append. You don't need to follow through it, right? And the question is, what if you have a if, if else inside your for loop? You can still do it. You can still do that. So let's say, let me copy the same thing. I want to add some more condition, right? So let's say you have this. You got for num is that. So I wanna, instead of append it, I wanna first see if I, right, the division by 2 is not, so I wanna see if it is add, so it's not equal to 0. If that is not, if it's not equal to 0, then I wanna append it here. Then I will say else, right? So else, then I can just do print out, print add. It's not print even here, but right. Or I will say else, just continue. If it's not continue, mean okay, maybe we need to talk about continues and then break and so. Okay, fourth line. Fourth line. Are you okay now? Mobolaji. Mobolaji, are you okay? You said fourth line. So I don't know which fourth line we. Oh, never mind. Okay, thank you. All right. So here we have else inside, right? So we still wanna do right. Now let's go with if only first. So you got if inside, then we wanna do this, right? So let's do that first, and then we can add else to it, right? So if it is add, we're gonna square it and then add that to our list. Right. So that's what you get here. So 1 square is 1, 3 square is 9, 5 square is 25. So if you want to do a list comprehension, we start with our I square, right? So I square, right? So I want to say I square, right? That's what we want for I in our num list, right? If I, so I will leave I the if condition at the end. If the division by I by 2 is not equal to 0, right? And if I want to see, I gotta have a list here, right? List here. So you get the same thing, right? Any question? Okay, so what if you have else and you got else inside? You can still make you can still write a list comprehension. So list comprehension is easy, it's quick, but it's confusing at the beginning. At the beginning, it's confusing. So if you feel like you make your code complicated, because sometimes you come within your own code, if you're not paying attention, it's very easy to get confused with a list comprehension. But it's very important that you apply list to it, because if I only run this, it doesn't give me. Okay. I want to run it here, right? My thing is usually this doesn't return a thing, but I'm surprised. Okay, maybe Jupyter Notebook has been updated, right? Usually you have to apply list to it so that you'll be able to see it. I don't know if somebody else is using another editor. Okay, so that's list comprehension. Let me look at the next thing. After list comprehension, I want to follow these. Okay, Lambda expression. So if you don't want to use, you don't want to use a space for a function, because that you want to use it over and over, you just use Lambda one time inside your code, right? And then you use it, and then that's it. You don't have to worry about it or any extra space or memory, right? So people use Lambda for those kind of things. So for example, I have this for loop. I can write a Lambda expression. I can say Lambda. I will take number, so space, your variable, and then you define the operation that you're doing on the variable. So let's say I want the variable cube, for example, right? Right, and then here I have to specify where this number is coming from, right? So it's coming from, let's say, my what is it? Num list. So from num list, right? Num list. So Lambda can do this for you easily, right? It will cube everybody from that, right? Yeah. Would you be great if you record and be available? I think they're recording it, right? They're recording it. Right, Stacy? I think they are recording it. Somebody asked that.
Yes. Yeah, it's being recorded. Yeah.
Okay, so all right. Give me 1 second. Okay. All right. So that's Lambda is very useful. You'll be using this a lot, especially inside your data frame, right? So Lambda expression, after Lambda expression, what do we do? Oh, map and filter, right? Map and filter. I guess that's the next one. Yeah, map and filter. Okay, so at this point, yeah, we should have defined function because map usually map a function to some set. So we gotta define function first before we come to map and filter. Let me go to functions. So in Python, functions start with def. Right, you wanna always start with a def. So def, the name of your function usually lowercase. So name of your function here, and then this open and close bracket. Some function take parameters, some function don't, and then you should always have this here. If it does take the parameter, then yeah, let me see somebody got questions. The best way I heard being explained. What is the benefit of this? Yeah, The benefit of this, you don't have to, is space memory. You use Lambda one time, that's it. But if you write a function and then you call a function, you are using space, you are using memory, right? Lambda just spaceless. You call it one times and that's it, gone. Yeah. All right, so you start with a DEF, the name of your function. If it does take parameter, then you put right here, params, right? Parameter here, and then you will have some stuff here, right? What you want the function to do, right? Some operation here, right? You have some operation here, or sometimes you might be just printing, or sometimes it might just be saying hello. And then some function return, right? Some function just print stuff, right? So this, you got these two options to return, right? Or you can just have a function that just print, right? So it will do, the function will do whatever you condition you impose here. So you define your function, you want some operation that take place, and then you want to return the results after the function is done doing that. Right, so let me comment these. Right, so basically that's how function works, right? So for example, let's say we want to write a function that will just take the square of every number, or square root, right, from our num list. So you will say DEF, right? Usually the name of your function should be similar to the job of the function, what the function is doing, right? So if I'm taking square, I will use somewhere close to that. If I'm taking root of numbers, so I would say root num, for example. So it becomes easy to, right, to remember. So I would say here, it will take num, it will take this parameter num, and then here, what I'm going to do, I will say this function, I want this function to return, for example, return num. Why my return is, or return num to the power 1/2, right? So power 0.5, right? Right. So, and then I don't have to specify the num list. All I need to do, I need to fit in any number in there, right? So if I say root of for 4, for example, that should give me 2, right? If I say root of 3, root 3, right? Root of 1 is 1. So it does that, right? So usually people write function, right? And then save it somewhere, and then every time they need it, they call it, right? It's easy to remember the function that you built to call it than the Python built-in function. Most of the functions that are building here, they are built in Python already. Python has a version, right? But if you can build your own, that's a good way to learn Python also, right? So that's how function works, right? And then this indentation is very important. If you come here, it will say indentation error, right? So the return and the def should not be in the same line, right? So you gotta have this. So let's go to other functions. So so def, so I will say add, this add function. So it would take parameters. So let's say first val, so val1, val2, right? So what it does, it will take this, it will just add, so return val1 plus val2, right? Or you can say here sum, define this variable sum equal val1 plus val2, val1 plus val2, and you want to return sum here. Right, so let's see, sum is a keyword, but let me see a sum. Right, so that's fine. Then that says our sum equal this. So if I call add function of 1 and 2, it should return 3. Right. So inside a function, you can have conditions. You can have condition inside your function as well, right? So let me see some of the example. Let's say we want to reverse a string. We want to write a function that reverses a string. So let me show you what Python built-in reverse is. So let's say you got A, B, C, D, that's your strings. If you want to reverse this, right? So it's S, you do this, double colon, and then you do -1. So that will reverse it. You see D, C, D, A, right? So let's say I want to build my own function that will do this. Right? So I can say df, I can call it reverse func. Right, so you take a string here. I'll just take val. Right, so, and I would say for character in this val, right? And I want to start with some empty characters. So I would say new string equal this. So I'm going to append, you see what will happen. So for character in this val, right, I'm going to them, and then I want to say new string. This new string right here, I want to new string is equal this val plus new string. So the position is very important. If I change the position, it will not reverse it. And then let me do this. And then I want to return it, right? Return new string. Return new string, for example. All right, so let's say I want reverse of yup. Oh, what happened? Let me run this. I got it twice. So for char, oh, it's taking yeah, I need to split it, right? So I need to split this, right? Because it's taking the whole thing at the same time.
Yeah.
So
I think if you replace var on line 1, 2, 3, 4, just below your cursor with char, because the four will split it, right? The for loop splits your var and puts it into char. And so when you, so on the next line, instead of var, if you make a char.
Yeah. Oh, yeah, yes. I'm taking char in there.
Yeah.
So is it called char plus new string there? I think, let me see, your boy, okay, very good. So now let's say instead of doing it, this is very important. If you change the position now, put it here. Yeah, it's a chart that I'm taking from the. So you see, it doesn't do it, right? I have some special word where the reverse give me Let me see, the reverse.
Actually, if you have character plus new string, then it works and it becomes boy.
Yeah, I need to replace it. So new char.
Just switch it.
Yeah, if I do this, but I have to new char on the right side. This is the case. You gotta have it to the right side here, right? So what was happening here? So it will go through my val. The first letter is, the first character is Y. So it will add empty string to Y. So you will have Y only. And then the next one, it will go to O. Then now it will add a O to Y. So it will be OY. Then the next one is B, then answer YO, right? Then the next one will be B. Then B will be on the right. So Y is there. Y is a chart. The chart is always on the left. And then the new one will be on the right side always, right? So Y first. When you come to O, then it will be Y plus O. When you go to Yob, so Y first. The next one you go to O, then it will become Y O. Then the last one is B, then it will be Y O B. Right? Become boy. I have a lot of words whose reverse give you some sense. I have them here. Because when I was yeah, if you reverse them, you get yeah, this, like all of these words make they have meaning, right? This, so I Googled word whose reverse give me another words. I think they have a special name for them in English. So this is a company that Oprah created. So when I reverse it, it gives her name, right? And then this one in reverse give you, so Yensid give you is a music band. So when you reverse it, it give you Disney, right? This company belonged to Oprah, which was interesting. Right? Maybe they look at her name and then reverse her name to give that name to the company that she owned. All right, so we can do a lot of stuff with functions, right? So now, because yes, so kind of like yeah, kind of palindromic. You know, they have to satisfy some conditions. They have to be prime and then so on like that. So palindromic is more than this, I guess. Right? If you reverse them, the reverse is equal to themselves, right? So if I want, that's interesting. So if let's say I want this to be a val instead of let's say a string here, because if I don't use this, if let's say I'm converting to a string, for example, now instead of this, let's say this is a palindromic number or somebody's, right? If I do this, it will give me exactly itself. So number who reverse equal themselves, and then they are also prime. Forgot about this, right? This is palindromic number also. Good point though. It's been a while since I talked about palindromic numbers, right? Okay, so right, so this function that right here does exactly the same thing here. The question is why you should do this. Sometimes you will have more flexibility with your own function. You can add some restriction to it, some condition than the built-in function itself. Okay. So we define functions. That's not it. So after that, the function lambda. Okay, map and zip. Okay, map and filter. So now we can map our square function. Did you define square or root function? Right. And let me make sure our num list is in this of yeah, it's in here. So we can map this. We can map our this square function or root function to this root function here. So what map will do for each member in the list in this list here, it will take the square root of them. Right, it will take the square root of all of them one by one and then return the result. Right. I think I have some good example here. Let me see. Map. Okay. Okay, so yeah, so we have our numbers and then we got this is 3 times, so this could be our root. And then if you want to see an output, you need to apply a list to it. Right, so we have the root function, so we can say map. So our roots, right, root function now is root num, okay. And then we're going to apply that to our num list. So it will take the square root on all of them. Right, so if I run it like this, then I will only get this object. But if I want to see some output, then I would say list here. And then this will give me the square root of every number that is in this list. So you can also use lambda inside this thing. Now I can use a map. So we have our roots. Let's see, lambda. So now I would say, and then I would say num square. Right, and then here our num list. Right, again, you don't see anything. If you want to see, I think, right, you need to do this. It will give you the square of all the number that is in this thing. Right. So you can use lambda or you can call your function inside, right? This is the function that we built. This is the lambda that we just did here. See, the beauty of lambda, you don't have to create an extra space for your thing. You just, call it inside of your, right? You will do this especially inside your data frame. You want to do something, you want to convert the date column to some specific format. You can just apply lambda inside of it. Right. Okay, so filter, right? So we want to filter, right? So filter, right? So you will be checking some condition and then you will filter those out. So you will go through a list, for example, our sequence from 1 to 5. So what this filter will do, we'll go through each one of them and then return the one that are square, right? So I would say filter, for example, right. So we want to check lambda. So say I have name, right? So name first character equal a, for example. Now I need to use our emp list here because I'm going through the list. So employee name, I think that's what it is, right? So it will go through each one of them and then compare the first character in the name and then return that, right? So if I want to see it, Then I gotta write the list. This here. All right, so that. And then again, if I want to get Abel, then I need to see here that lower, right? Lower. And then the lower case for this, then I want to have Abel inside of it. So filter, it will filter out some condition, right? It will give you the one that satisfies that conditions, right? However, map, can you have all condition in your filter? Also consider low temperature. Yeah, you can do that. Yes. So you can say equal this, or right, you can have this condition. I don't think I did this before. That would be or if it is the upper equal this. I never done this inside Lambda, but I think it's possible. So if employee first name in lowercase equal that, or in uppercase equal this, and we want to return that, right? So, or we got two conditions here, right? So let's see. Yeah, it does, right? It does. Is that what you mean? Okay, yeah, so yeah, you can do that. All right, so filters, no problem. So let's say we want to, let's say temperature equal this, and we will have 0 degrees, 0, 10, 20, 30, 31.5, for example. And then we want to convert these. These are Celsius, right? Celsius, that's a Celsius 10 for this. And then we want to convert it to, Fahrenheit. So Fahrenheit temp. So we can use list comprehension here, right? So what do we do? I think the conversion is what? 9/5. Is that it? So 9/5 times, let's say T plus 32 for T in Celsius. So I'm hoping that this formula is right. I think 9 over something, right? So you can use list comprehension to do that, right? For T in Celsius. So it will go through these and then just do it, right? Question, message, no message, okay. All right, so, right. Let me see what is complaining about. Oh, comma, right. So if I look at temperature in Fahrenheit here, all of them has been 0 degree equal 32 degree Fahrenheit, right? So think about it, you can use Lambda also to do this. Right. Questions. Oh, 5/9. Oh, this is when you want to go to from Fahrenheit to degrees, or from Celsius to Fahrenheit. Oh, from Celsius to Fahrenheit. But Fahrenheit is the biggest one, right? Yeah, Fahrenheit is bigger. So I believe this is Fahrenheit. Celsius is the reverse.
Yes, you're right.
Oh, okay. Okay, so that's that. I got a lot of examples of functions. Okay. So now let's we got up to filter. Okay, we'll cover all of these. If comprehension, lambda expression. Okay, I got 2 questions here. How to limit digits to accuracy? I think there is a way to format it, right? I think there is a way to format it. Let me look at the second list. Oh, we didn't talk about range and length, right? We talked about length, but I don't think we talked about range also, right? I think that's something that we need to mention. Okay, so Celsius is 5/9 times Fahrenheit minus 32. Yeah, that makes sense. We can even do that, right? Okay, so let's look at this example. Maybe I should let you think about it for a few seconds. So we want to write, I have an exercise here, find the numbers or counts, let's see, counts primes numbers, primes, okay. I would say write a function that returns the number of a prime number between the axes, that return the numbers of primes numbers, right, that exist, right, the number of prime number that exists between, so I would say between that exists up to including a given value, right? That exists up to including a given value. So here we need to discuss range first, right? Because if you want to include the given value, let's say for example, we want to include find the number of prime number between up to 100. So from 2 to 100, right? So let me put this as a markdown cell so that it becomes nicer, right? So we need to discuss range. If you see range, right? Let's say for I in range of 10, for example, print I. So this will print from 0 to 9 because range does not include the endpoint. So I would say print I here. So you see 10 will never show up. So if you want to print number from 0 to 10, 10 included, then you need to have this, right? So from 0 up to 10, you need, the last point is not included. So you can also indicate the starting point, right? The end point and the step point, the step size. So 1. So from 0, you come to 1, 1 to 2, 2 to 3, up to that, right? So in this case, you get the same thing, right? If you want only even numbers in there, you can do that, right? If you want only odd numbers there, so from 0, you do that, right? So range does not contain the start point, the last thing. It does not contain that, right? So that's something that we need to keep in mind. So if we want to get prime numbers that are between, let's assume that 1 is not part of it. So 0 is not a prime number. So we want to start from 2, right? 2 as the first prime number. So from 2 up to 100. So include 100, right? Then we can use range here, right? In fact, you can use range from, we can use the beginning to be 2, and then the endpoint to be 100 and what? If I want to include 100, what should be the start point? Anybody? So let's say def, we wanna call it count prime. It will count prime numbers, right? So those prime numbers, now we know that 2 is the first prime number. So let me start by initializing this prime is a list that contains 2, right? But I'm going to find others, right? I'm going to find others. And if I find all of them at the end, I'm going to measure the length of these primes, right? If we have 2 elements, then right now, if I take the length of this prime, let me do it here, it will just be 1. It is a list that only contains 1, right? But I will be checking for others. Now, if you do length of primes is only 1, right? So that means it's only got 1 prime number is in there, right? So let me delete this. So the objective is we're gonna look for others prime number that will be going to these prime numbers. And then once we exit the list, then we're gonna measure the length of these prime numbers, right? So I will say x equal 3, for example, right? Why I'm doing this, I'm gonna be checking numbers that are between 3 up to our numbers, the number that is given, right? Because 2 is the first prime number, and I will keep on adding from 3. I will keep on adding 2 to it. So from 3, the first, if I add 2 to it, that becomes 5. So 5 is a prime number. If I add another 5, 7 is a prime number. If I add another number, it becomes 9. I have to check every time I add 3. I will check if it is a prime number, then I will append that. I will append that number to our primes. For example, if I add 3 to 2 becomes 5, 5 is a prime, it will be appended to our prime, right? So to do that, we're gonna roll out the case for 1 and 0, right? So we'll say if we pick a number that is, we want to find, if a number is less than 2, right? If that number is less than 2, then we're gonna return 0. There is no prime number between that. So return 0, oh, not O, right? So now, if else, now we wanna check why the number is, our X that we hear is less or equal to our numbers. And then we're gonna increment it. So we rule out 0 and 1. Now we wanna see while X, right, is less, we wanna put equal because up to including the number that is given, right? Less or equal to numbers, right? Then we wanna say if, right, Y, so for Y in the range, this is why it is interesting to get X equal 3. So for Y in the range of X up to number, up to num, right? So we want to see for Y in the range of X is increasing, we're increasing X will go up to N. So I want to say for that, and I will increase the step size 2. That's what I'm doing. So the first number is 3 at that. The second number will be 5. If it is a prime, I will check that later on. So now this is what Y will go through, right? Y we're going through this range. The step size is 2, right? Remember here, if you change the step size to 2, it will keep on adding 2 to 0. So 0, 2, 4, 6, and so on. So now we want to check if, right, the remainder of X and Y, right, So we want to say if you divide X by Y, if that remainder equal 0, right? If that is equal 0, then what we're gonna do? What does that mean? You remember X can go up to N. So, and then Y is in this range. So let's say X equal 5 or X equal 15. Let's say Y equal 3, right? If it is a divisible by that, then we're gonna increase X. We are going to add 2 to X, right? So if it is divisible by that, then it is not a prime. If it is not a prime, we're gonna break it. Break, right? So if that doesn't happen, right, that means it's a prime, right? If it doesn't divide, then this thing is a prime. Then I wanna say else, right? You notice my else statement is aligned with the for loop, right? Because I have a break inside my for loop here, right? So if this doesn't happen, then I'm out of it, right? Then I want to see, that means I have some prime numbers here. And then those prime numbers will be appended to my prime. So then I will say our primes, I will say that append, right? Let me put it up a little bit. So that append X. Now we're going to increase still. Right, the step size is 2 always, so the new X is equal X plus 2, right? And then at the end, we're gonna say, yeah, range, you're right. I forgot the range, thank you. In the range here, thank you. Right, so then now I'm ready to print. I can print the primes. I can also print the length of that, right, or return. So let's print first. Print primes and I return the length. Print primes, and then the function will return, right, returns length of our primes. Right. I have a feeling that this is more mathematics than programming. Right, so let's see. I want to print this here. So let's say primes of 100, for example. Right, so that's the it print all of them, and we have a number that, so there are 25 prime numbers between I would say between 1 and 100s, right? But I think this is the tricky part, right? You keep adding 2 to 3. Why I do that? 2 to 3, you keep adding the steps like 2 to. Those numbers are more likely to be or even. But if you take 2 here, any multiple of 2 will not be prime numbers. Any multiple of 2, 2, 4, 6, those will not be prime numbers, right? Okay, so questions? Okay, so we can take a break and then come back. It's 12:52. We can come back at 15 minutes, 1:07.
Yeah,
is that okay?
John, I think John and Stacy and Nana.
Yeah, that's fine. That 15 minutes is fine. Yeah, so everyone, Dr. Dumbia is here, so we'll start in a minute. So as I said in the beginning, check Slack, and I believe also in the chat area for the evaluation link, and then do complete the evaluation. Also, again, make sure you sign in for attendance, especially if you intend to get certificate of completion for this training. To get the certificate of completion, you will need to attend at least 6 of the 8 sections. All right. Yeah, Dr. Dumbia, so it's all yours again.
Okay, so we're gonna do some little bit of math, some operation with vectors and scalars. We did a lot of operations with single scalar, but we're gonna take it to a new level. So let me just stop here, SymPy and NumPy. So NumPy is just like a linear algebra library for Python, right? So SymPy is like the MATLAB version of Python, right? So to use this library, I'm gonna import them first. I would say import NumPy as NP, and I import, by convention, people use as NP, so you can use any name that you want, and SymPy as SY, right? So I want to import these two. In fact, yeah, let me limit myself to those. So I can create an array for array of NumPy arrays. So I can define the following. Some people still have a problem to sign in with that Slack. Okay, so my first array I would say is equal to NumPy. I already called it, so I would say that array, and then I can fit in here a list. So let's say list 1, 2, 3, 4, 5, right? Then, right, so let me define a second one. So the second one is this. So I can put this 5, let's say -11, 0, and 2, right, randomly. So we have these two. If I check the type, if I say array 1, right, array 1 underscore 1, right, is an array, right? So the difference between these, it looks like a list between that and our conventional list. Let me see here if I can create a list here. Let's say L equal this, 1, 2, 3, 4, 5, right? So let's say I do L times 2, and look at the result. So it's just multiply that list. You reproduce it again. Are you saying to make it easier? Okay, right. So if I mean to multiply every member in that list by 2, but this is what I get, right? However, if I take array 1, right, array 1 times 2, that's exactly what we will do, right? So it will go inside and then multiply, element wise, multiply everybody by 2, right? So this is the same thing as L plus L. So if I do L plus L, right, it's the same thing, right? However, if I do R1 plus R1, it will be different from this, right? So we can add this array 1 plus array 2, 1, right? So plus array 2, array, right? We can add it to become a new array like this. We can also multiply them, right? So there is a lot of way to multiply an array. You can also check the length, right? You can do array 1, right? So let's say dot. So this is dot product between the two. So that's array 2. Array 1 dot array 2. Right. So this should return a number, find a scalar, right? So instead of that, you could use also, let me copy this, array 1, right? You can do array 1 at. So at symbol will also do this. The at symbol will do it. What happened to my at symbol? Shift at. Yeah, so that should also give me the same thing, right? But the hardest way is to loop through it, right? So you can say, you can go through it. So that, you start with that equals 0, and then you loop through it. So you pick element wise. So for I, J in, right? So you go to, let me zip it. So zip in zip array 1, array 2. So array 1, array 2. For IJ in that, then we are going to multiply component wise. So I will say my dot, right, is equal, my dot plus is equal to I times J. And then I want to return look what the dot look like, right? So this should give me 2 also, right? Right, so you can do that. You can also do square root. You can take the square root of an array. You can broadcast array, right? So you can add numbers, or you can access elements. So for example, array 1, if I want to get the first 3 numbers, I will say from the first up to 3, right? You see index 0, that's the first one. Index 1, that's the second one. Index 2, that's the third one. And then you remember this does not contain, it does not include 3. 3 is excluded. So this should return the first 3 members of our array 1. So 1, 2, 3, right? So if I only want the last number, then it's -1. If I want only the one in the index 2, like this, right? So like this, you can do those the same slicing that we did in the list. So now you can replace, let's say I will say I'm replacing in array 2, I am replacing, let me see, array 2, for example, I'm replacing the second number by 100 because it's negative. So you can say array 2 at 1, that's the second member, equal to, let's say 100, right? And then if you look at, 100. And if you look at array 2, right? So that -9 has been replaced by that, right? It has been replaced by that. So you can also create, so let's say array 3, you can use this array 3, I will say up square. So from the beginning to the end, that's what this means, right? I want to say, I want all of them to be some numbers. So let's say 0. Then if I print this array 3, I will get 0, 0. What did I do? Array 3 at, I need to define array 3 first. And then I'm going to replace all of them by this 0. So array 3. I would say array 3 equals something here. Array 3 equal a 2, 3, 11, 5, 75, 22, something like that. And then 8, 9. So this is my array 3. And I want to say replace all of them with a 0. Array 3 equal that. Cannot iterate. Let me look at my array 3. Okay, let me see from 0 to 3, for example. I wanted that to be equal to 0. Okay, only iterate assigned variable. Let me take this out. Only one can only assign iterable. Let me look at my array 3 again. Yeah. Okay. See, that's 0, and then look at array 3. So look at it now. That has been replaced by 0. So I was trying to slice it.
Now, do you need for multiple indexes? Do you need multiple assignment? So it's saying that,
I wanted to assign from 0 up to 3, for example,
0,
all of
1,
them.
2, 3.
Yeah, I wanted to replace them by 0. I don't know why it didn't work.
Can we try the 0? Let's repeat. Let's make it like a set 4 zeros and see.
Like
it should have worked. Yeah, it should have worked.
Like this?
Yes. Oh no. Square bracket, which is a
list.
The list, yeah, and then 0, 0, 0. Yeah. 0. Let's see if it's positional. It shouldn't have been, but
yeah, it should have worked. Oh no, this one worked.
Yeah.
Wow.
Yeah, this is saying, because your number is 0, 1, 2.
Yeah, but I used I think I should have went just I used to set it just equal to 0.
Yeah, I should have went.
Yeah.
Something.
Yeah, but something is going on. Right. So you can like us. Hey, hold on 1 second. My Wi-Fi on campus is not stable, so I'm teaching from home. Sorry about that. Yeah, so we have the option to replace some members, right? All of these are important. Now we can build, the most important thing about this thing is matrices. So we can build matrices of these. So let's see, my matrix equals, so first I want to build it of array. So Numpy that array, let's say I want to build a 3 by 3. So they have to be inside a list. Your rows has to be inside a list. So you have a list of rows. So row 1, comma, row 2, comma, row 3. If you want a 3 by 3, it has to be, they have to be inside a list. Now, and then each row also has to be inside a square bracket. So let's say I want a 3 by 3 matrix, for example. Then I'll do this 1, 2, 3, right? And then here 4, 5, 6, and then here 7, 8, 9, right? Then if I print my matrix, it should give me that 3 by 3, my maths. Right. So is that, so the difference between matrix in SymPy and NumPy, This is not the usual way that we used to see matrices. Simple will print it the way we used to see. So let's say, I will say simple maths. So here you will say SY, right? So you want to apply that to a matrix, right? So you gotta have an object matrix in there. Capital M, if you use lowercase m, it will not work. So now you can specify, let me copy this and then paste it here, right here. Right. So I have my list of rows in there. Then if I print simple matrix, simple math, this is what we are used to see matrix, right? But they're all matrices, right? So we have a lot of type of matrices, like 0 matrices, 1 matrices. So if you want, for example, if you want to build a 0 matrices using NumPy, so I would say Z equal to, for example, np.zeros, and then if I want a 2 by 2, I would mention that here. Right? If I want a 3 by 3, I would mention that here, the dimension here. But you have to mention the dimension. So if I look at Z, right? Let me see. Z is a zeros matrix, right? And with NumPy, you should take a tuple, let's say 2 by 2, right? With NumPy, you gotta enter as a tuple here, right? So it's a matrix with all entries zeros. Right? You can do the same thing with NumPy, with SymPy, right? So SY, so is equal SY dot zeros, and then here, I think it doesn't take tuples. Let me see. Yeah, you don't need tuple for that. You just enter them one by one. But with a NumPy, you gotta enter as a tuple. So that's the difference. You're using NumPy, you gotta enter the dimension of the matrix as a tuple. But with SymPy, you don't. You just enter your stuff there. Right. So we have things called ones. Right. So let's say O or ones is equal in NumPy is NumPy that ones, right? Then you specify the dimensions, right? So if you look at the ones, right now, if you want it to be 3 by 3, then right, that has to be a tuple also. So it's a 3 by 3 matrix, right? So if you want to do the same thing with SymPy, so let's say ones. So that one's equal SY dot ones. And then you're gonna specify the dimension here, right? Let's say 3 by 3, right? And then if I look at ones, right, is that. So the identity is eyes. Maybe we should write here matrix with all entries once. Right, so using SymPy. Right, I really want you guys, when you're doing this, have some notes. Matrix with entries using NumPy. Right, you do the same thing for these. So identity, you just let's say I equal and NumPy dot EYE, right? And let's say we want a 4x4. So let's look at I. Right. So for this identity, even if you are using NumPy, you don't need a tuple. You just enter the thing. This is import NumPy 3x3 equal the.
Primarily, what I'm saying is for visual, SymPy seems to do a better job than NumPy because it gives you, like you said, so it gives you that visual.
SymPy, you do everything you do in NumPy, you can do in SymPy. This, but SymPy is, but in data science world, people use NumPy a lot. Right. Few people use SymPy. I use it for when I teach data science. I use SymPy, but okay. So if you want to use identity using SymPy, so let's I4 or I5. I want to use a 5x5 is sy dot EYE also, and I want a 5x5 matrix. Then let me print it out, I5. Right, so it's a 5x5 matrix, identity matrix. Right. So let me create a matrix. And then using that matrix, we're gonna get the diag, or maybe my maths. Right. So there is a method called diag. It will return the diagonal entry of your matrix. Right. So you have the so let's say D equal SY diag my math. So let's look at D. Let me, instead of math, let me use an NumPy here instead of SY. I think they have different meaning. So it means 1, 5, 9 are in the diagonal. So let me print my math here. My math, 1, 5, 9. So that's what is in there, right? So let's say D1 equal NumPy dot diag. So instead of assigning matrix in here, let me assign tuple. So let's say 1, 2, 3. 3 here, and then I want to look at D1 here. So we will return. So this is like an overpopulated function. So it will return a matrix with diagonal 1, 2, 3, 1, 2, 3, 4, right? So D2, let me see if I simplify the diag. Right, then I want to do this. That's give me 1, 2, 3 equal D2. I think there is an error here. Let's see, it just returned that. And then if you put it as a list, then it will just return you that column matrix. Right. Okay, so diagonal, what else we can do? Inverse. Yeah, we can do inverse of a matrix also. But you gotta make sure that the determinant of the matrix is not equal to 0. Right, so let me check np.det of my maths. My maths, is it copy still? np.det. Let me see if I do my math. So I say IMV is equal to mymath.inv, for example. So I need to call linalg on this one, right? So I need to call linalg numpy.linalg.inv, then it will work, right? But with simply, I can easily do this, right? Let's say, did I build any matrix with simply? What that is invertible? Let me see. Okay, simple math, right? With simple math, I can do this. I can say so that INV, right? Simple math.inv. So this should return the inverse of this simple math. So let me look at this INV here. What? It's not invertible? The determiner equals 0. So that's very important. So let me just change it. My simple math, I'll just change something in there, right? So this is 0. Let's say this is 11. I think it should work now. Yeah. So if you look at it, so this is the inverse of our simple math, right? So we can do the, we can multiply matrices together too, right? We can use an @ symbol. We can also use a mat_mult method, right? So if I want to make sure that simple math and then INV are inverse of each other, from algebra, linear algebra, we'll do the multiplication. So that simple math, if I do that, it should return identity matrix because they are inverse of each other, right? If this doesn't, order shouldn't matter. If it's a simple math, that mat_mult and INV here, right? This also should return. Actually, I should do this mat_mult. Let me simple math. I'm doing mat_mult between these two, so I call them. Order doesn't matter. So let's do this. That. Right. So they should return identity matrix also. Right. So you do. Actually, let me reverse the order here. Put that. So I want to use INV here. So I'm multiplying simple by INV. Either case, you should get 1, right? But you can also populate your matrix using random numbers, right? So you just need to specify what type of random number you want. You want random integers. You want numbers that are uniformly distributed between 0 and 1, or do you want, right? So let's say, for example, R for random number is equal, I will say, let me use a simple matrix so that matrix. So inside here, I'm going to call random's number. Oh, I didn't call random, did I? I don't think I called random. So I'll just say import random here because I'm going to use it. So I need to call it before I use it. So import random. Right. So now I can call the random thing here. I will say numpy that random that run integers. So run int for integers. And I want, let's say, for example, I want integers from -7 to +3, right? And I want it to be like a size to be equal a 2x2 matrix, for example. I'll have to specify size equal a 2x2 or 3x3, so 2x2 matrix. And I want to print that matrix R, right? It is a random matrix because if I run it again, look at this. This is -2, -4, -7, 6. Let me run it again. You see, I get another matrix, right? If I run it again, every time I run, I get different matrix, right? So SY. So if you want to get diagonal with SymPy, I believe you gotta enter the thing, the diagonal numbers with just nothing. So let me copy these. So D4, I don't know if I have D3. So you don't, if you take this, you remove this, then it will return a matrix, right? You return a matrix with diagonal 1, 2, 3, right? So that is a little bit SymPy and NumPy, the syntax are a little bit different. With NumPy, you need to put this between parentheses, but with SymPy, you don't, right? So in addition to that, what else can we do with the matrices? You've got random number, random integers, right? You can manually enter them, right? So you can also populate them with numbers that are normally distributed, right? So now let me look at somebody has a questions. Yeah, transpose. Yeah. With SymPy, let me see. I think with SymPy just be that transpose. I'm not sure if it's capital T, that T. Let's see that. Yeah, that capital T. So, did he reverse it? Let me run it again. Transpose. Okay, what is going on? Let me run this. Okay, it is changing it, right? It is changing it. It is a transpose. So I think capital T also work. Let me see. Capital T should work also. Let me run it again. And yeah, it transposes, right? It looked funny because let me increase this number and then let me go to 3 by 3, for example, 3 by 3 or 3 by 2. So let's see, right? Yeah, so it does work. So capital T work, or the word transpose works also, but it's a method. You need to have that, right? If you use the word, you gotta have that, right? So matrix multiplication, did I do that? Yeah. So instead of add symbol, you can use matrix multiplications. Inverse, we got that. So let me see, add that DT. Right, so that will return the determinant. So this is the determinant. So now the next thing is grabbing any element that you want, right? So if I have R, sub, if I just say 0, right? So it just tell me the first entry here, right? So if I want to grab an element that is in the all the first rows, right? All the first rows, then the columns, I want only the first columns. First rows, first columns. I mean, all the columns. right? So I would say this. First, let me grab up the first two. So if I want first two on this matrix, that's this, right? I want the first two entries, right? And if I want to grab all of them, so I can just say from here up to 3. So that will return the first row, right? 4 to that. Right? If I want first row, let's say only first column. So I would just say from 0 to 1. To 1 will be excluded, right? From 0 to 1. So that first row, first column, that's this, right? First column. But if I want 2 columns, so I'll first row, second 2 columns. So column 1, column 2. Then I will have a 3 by 2 matrix now, right? So I got this first row, but I got 2 columns, column 1, column 2, right? What if I only want the first 2 entry in the rows? So I'll come here and then the first 2 columns. Then I get a 2 by 2 matrix, right? So I really encourage you to play with these, how to grab a specific element. Right. So as a data scientist, you should be able to get any information out of your data anywhere, no matter where they are, right? So that's how you do that, slicing. And then another way you can do for slicing is all. If I do this, that means I want all the rows, right? All the rows, but I only want the first 2 columns, right? If you want everything, then you do this, all the rows, all the columns. So it's an entire matrix, right? All the, yes. Okay, right. So that's that. So we have a determinant, transpose, adding. You can add matrices, you can subtract them, but they have to have the same dimension, right? For you to be able to add 2 matrices, they have to have the same dimension. For example, if I add R and D, I can add them, R and D4. So R plus D4, that's possible, right? Because they have the same dimensions, right? I can do R times D4 also, R times D4, because the number of columns in R is equal to the number of rows in D4. That's possible. But let's say I have a M5 or M1 equal, let me just say M equal this, I have a 2 by 2 matrix, for example, or let me just use a simple matrix. And I have this 2 by 2 matrix or 2 by 3. So this is 10, 12. And then here I have 20 and 1. Right. So it's a matrix that have 3 rows, 2 columns. So the 3 rows here, -4, +2. Right. So if I look at this little m, it has 3 rows, 2 columns. And then here, this matrix R has 3 rows, 3 columns. So the number of columns in R is equal to the number of rows in M. So that as a result, you can do R times M, because the number of columns in R is 3. The number of rows in M is 3. So I can do the multiplication, right? That or at, I can do this. That's possible. But if I try to do M at this, M times R, this is not possible, right? Because the number of columns in M, right? Impossible, because the number of columns in M, matrix M is not equal to the number of columns, I mean, a number of rows in matrix R, right? So you got two matrices. For you to be able to multiply them together, then the number of columns of the matrix on the left should be equal to the number of rows to the matrix to the right, right? So this is not possible. Right. So addition also is the same. You cannot say R plus M, right? They don't have the same dimension. They have to be exactly, because they do not have, because the dimensions are different. So for you to be able to add two matrices, they have to have exactly the same dimensions, right? Same thing with minus also, right? Okay. So you can delete a specific element. So let's say, I think del is a word that del. So let's say, so R. So if I say del, let me print R here. Right, I think you can use the delete thing. np.del. Is it delete? You can delete a component from there. I think I should call an empire or what? Right, and let me look. Size. Okay, there is something that I forgot. Lane space. People use lane space. Lane space, not line, but lane space. Right. So we can use lane space to populate your matrix. So, for example, let's say my L is equal. I want to have like 25 number, for example. So I would say is np.lane space. So I would say numbers from 0 to 25. That would be 25 numbers. And then I would just say the step size is 1. Right. So if I look at L, it would just be 25 of them. Lane space or np dot lane space. Right. So let's look at that one. 25 of them. Actually, I want 25 of them, not one of them. I want 25 numbers that are equally distance between 25, between 0 and 25. Right. So if I look at the length of my L, if I look at the length, it will be 25. If I print L, it will give me those 25 things. So I have these 25 numbers. So that means I can build a matrix of it. So I can say M5 is equal L direct shape. So this is important. The number of element here must be equal to the product of this dimension here. So I would say reshape to a 5 by 5 matrix. So 5 times 5 is 25. We should get exactly 25 number here. And if I print M5, you will see it's a matrix that have that is a 5 by 5 matrix, right? If I change this to 4, for example, 4 times 5 is 20, and however you are reshaping 25 numbers. So that is not possible. You gotta be careful. Okay. So you reshape, the product of your dimension here should be exactly equal to the number of elements that you have over here. Okay, so now let me think I've said about NumPy, SymPy. Okay, you can also write your matrix in a reduced row echelon form. So you just REE, this method, reduce row echelon form. Right. So, for example, let me look at one of NumPy metrics. You can easily find its reduced row echelon form using that. Right. So my multiple this. As long as it is invertible, I shouldn't get an error thing here. Maybe I need to check out the invertibility of this matrix. I think it was invertible later on. One thing I want to mention about these matrices, zeros, namespace, reshape. We have a determinant. Yeah, and then we know how to do the product. And then you can also write a for loop to do the product through them, do it component-wise. So M, you can use the dot product, NP dot. I think you can fit in the both metrics here. So let's say R, the product of what two matrices is possible. Let's R and M. R and M. So this should also give you the product, right? Instead of doing, some people like to do R dot M, so capital R. I believe they both give you the same thing, R dot M. So NP, NumPy, I forgot NumPy, right? So NumPy dot. Okay, so yeah, so that's pretty much what I wanted to cover about NumPy and SymPy. So keep in mind everything that you can do with NumPy, you can do with SymPy. So the next thing that I want to do, let me go to day 2. Oh, I don't have it here. So I want to go over Pandas. And in addition to Pandas, we have some requests yesterday. So we're going to talk about classes, right? Object-oriented. We're going to talk about some object-oriented method and just some Pandas, handle data set with Pandas, and then move on to visualizations and then web scraping. That's what. Okay. So feel free to also look at the documentation of NumPy, right, and SymPy. Okay, any questions? I don't want to start a Pandas now. If I started, we will not have enough time to. We only got 4 minutes, unless we can go further. Panda is a huge topic, so this will be next.
You mean, Dr. Dumi, are you doing this now or next time?
Yeah, I think we don't have time unless we. When do we start? We start at 2?
Yes.
Okay, so I can't do it. Panda is a huge topic.
All right, let's do it when we come back then. So again, thank you so much, Dr. Dumbia. I mean, if you were here last week during the lecture on foundations of data science, the importance of mathematics and algebra, calculus, matrix algebra was highlighted. So if you want to become a Python programmer at your fingertip, then these are some of the things you want to know, unless you just want to be a programmer and then just use, a user and they use some of the built-in tools, but these fundamentals are very essential for those who want to become Python real programmers. So again, thank you so much, Dr. Dumbia. We are not meeting next week. As I said, the host institution, which is Howard University, will be on spring break, so there wouldn't be any lectures, but we'll come back the following week, which is March 17th and March 18th. So you have 2 weeks to grasp that stuff that were presented this week and last week. And then when we come back, Dr. Dumbia will continue with the introduction to Python. So that will be Python 2. So I'm sure as we get in there, then it will be more challenging. So I will entreat you to, especially if you're a new user, if you're a beginner, to go over the notes. The recordings will also be posted. So if you want to check on those two, you can check from Slack on where those information are posted. So again, Dr. Dumbia, thank you so much for an excellent introduction to Python, and then hopefully we'll see you in 2 weeks. All of you, not only Dr. Dumbia.
Yeah, thank you.
Okay, those going on spring break, enjoy your spring break, and then be careful. Keep yourself from any trouble. Get yourself busy with the Python that will keep you from trouble. Yeah. All right, bye-bye, everyone.
Bye. And please check the TA channel.